Hello everyone, I'm Xiao Gang. This is the final episode of this small case. Actually, we're all pretty relaxed now. We don't need to write any code here. We just need to connect the blueprints. This blueprint should be quite simple. You can see that it actually allows you to implement a state machine like this. Since it's first person, the main focus is on the hand movements. First, we need to prepare our animation assets. These assets have already been prepared for you. Actually, for these assets, we usually can download them from some websites or buy them from the Unreal Engine marketplace. And if it's more commercial, you might go and commission someone to make a package. Yeah, and actually we can also do it in the engine now. Keyframe it ourselves or use third-party or fourth-party software to keyframe it, that's fine. And here they have prepared 5 assets. The 5 assets are roughly these 5. So these 5 animation assets are actually the idle state and the run state. And what's worth noting is that this state machine is quite standard, meaning we have the jump start, the in-air loop, and the landing. These 3 animations. But it might be because let me think, first-person perspective. It probably doesn't have other body parts. So we don't need to worry about that. When we import these animation assets, pay attention during you must select the corresponding skeleton because you are not. UI Jota resource made with this skeleton. If you export it this way, it will sound distorted. It will become deformed. It might even blend into a messy sound. All of these are possible. Then we can, if you want to use other animations, you can try retargeting, because after version 5.4, retargeting has become much easier to use. There are also some bugging features. After importing, remember to save immediately. Otherwise, it will have signal issues. Then this side creates for the app. Animate blood punt. Then in this place, we use the designation, our negative class. Actually, this class, we can write it in C++. This is completely fine. Then afterwards, we put it here. Then we start making the variables for the state machine. These are the variables for the animation state machine. First, it determines the 2 states, running and falling. So these are 2 booleans. Then in this blueprint event graph, we update this detection state every frame. First, we need to get the owner of this animation blueprint. Then we obtain it through this node. At the same time, we need to cast it once, convert it to a character or similar, because only by converting it to a character can we access our movement component. After obtaining the movement component, we can get the current mode, because this movement will automatically determine if we are in this following mode. Then we set our following to update the following boolean. It will be more direct to use a boolean for judgment later. Then after that, we will determine whether the player is in a running state. Then we need to determine the speed. Actually, this part here, get a velocity, is to get the scalar value of the velocity. Then convert the scalar value into its magnitude, into a numerical value format. If this value is greater than 0, then we consider it to be in motion or running. Actually, yes, then we update it like this. And this part here, you can directly use this actor through the character's explanation. You can obtain this speed. No problem at all. So now we have these 2 judgments. Then after the switch, we start writing our animation graph. So first, right here, we declare an animation state machine. For the state machine, we check to make it an outpost. Now let's start by selecting our basic state. Obviously, our first state is the idle state, right? Then we just need to give it the idle animation. Just hook it up. So this detects the state within the idle state. Then we have 5 states. Actually, the transition between idle and run is based on speed. And the way they transition between each other is actually based on this following boolean fragment. So here we start connecting the pins of our animation state machine. And there are some transition conditions here. Obviously, this is based on running. This allows a simple back and forth transition between these states. And here will be a, isn't it running? Add a not, then after the not. Here we add a jump transition. Obviously, your idle and run, they both start with star when they begin to jump. So as long as our following state starts with star, we transition to this jam star place. Then we just pass it in here. Then it starts looping and under looping. At this point, it needs to determine this. So how do we transition to this loop? Actually, it's when our animation is about to finish playing. Then we put it into this loop. Then when do we transition to this ending animation? That is when our falling state changes again. We made a change, this landing, the landing state, and then finally, so when this landing animation finishes playing, we add an automatic wrap and then set it to the idle state. So our animation blueprint has been created here, and at this point, we need to, in our scalar parameter, specify the animation blueprint to use. That's quite simple. Okay, we then implemented a thank you all